Good morning guys, welcome to the Academic tutorial. Thanks for watching our videos online. Please if you haven't subscribed, please go ahead and press subscribe button and notification bell. That's our update on this YouTube channel. Thank you and God bless you. Today I'm going to be considering Neco 2022 chemistry practical under the branch of qualitative analysis. I've discussed about the volumetric analysis, and this year we are given what? We are given the two salts labeled X and Y, and these two salts are inorganic salts. Basically, X is what? X is zinc carbonate 4. It's an insoluble salt. And what? And Y is what? Is aluminum chloride, which is a soluble salt. Now we have to what? Carry out the following exercise on X and Y. Record the observation and identify any gas involved. State the conclusion you draw from your results of each test. Now, on X and Y, we have performed the following test. And the first test there is what? Dissolve all of X in about 10 centimeter cube of distilled water. Now, the 10 centimeter cube of distilled water, we have to dissolve X. And this here is X, zinc carbonate what? 4, I'm going to take what? 1 spatula of this and dissolve it in what? In 10 centimeter cube of distilled water. Here's my test tube now. I'll mix it with what? With distilled water. Now I'm going to what? Add 10 ml of distilled water. Now 10 ml of distilled water, that is 10 centimeter cube of distilled water. Then 10 centimeter cube of distilled water here we have. So now we have to stir thoroughly. Now when you stir thoroughly, what do you observe? What is our observation? You can see there's a what? There's a cloud solution formed here, which shows that what? See, you have what? A white precipitate here formed, which is insoluble. So C is a soluble what? It's insoluble salt. Now we have the serial number here, the tests, observation, and then what? The inference. The inference. Now, under this one now, the first question under A was X plus distilled water. X plus distilled water, H2O. What we are observing here, we have white precipitates insoluble in water, in distilled water. In distilled water. Now, meaning that what? X is an insoluble salt. X is an insoluble salt. Now, the next question now says, to the first portion of the solution X, add sodium hydroxide in drops and then in excess. Now, let's first write the question out. To the first portion, then I need to maximize my space here. So we have to the first portion, that's number 2. First portion of solution X. First portion of solution X plus sodium hydroxide in drops. Comma, then in Essex. So what we have then in Essex, this is the next one, the next practical or next analysis that we must carry out. Divide this into 3 portions. Trying to rinse to ensure that there's no water again inside this. So now, first portions, second portion, Then the third portion. So now to this portion add sodium hydroxide in drops. You can see there is still white precipitate in drops. So white precipitate form in drops. White precipitate, white PPT formed in drops. Then in essence now, what do you suspect? Whenever we have white precipitate in drops, what do we suspect? We suspect zinc ion and aluminium ion present. So these are the likely ions, that is the cations that are likely to present in in solutions, since we still have light white precipitate. It's almost getting to colorless, but let's add it in excess. Now you can see that the white precipitate turns dissolved. The white precipitate dissolved in excess sodium hydroxide, as you can see. So we are done with the first analysis. The white PPT dissolved in excess sodium hydroxide. So one thing you can be sure of is that iron 2 plus and aluminium 3 plus are very present, because these are the two ions that have the ability to form white precipitate and dissolve later in excess sodium hydroxide. So that's why we can say that yes, we have zinc and aluminium present. Now the next analysis here now is is to take the second portion of of solution X and add ammonia in drops and in essence. Now second portion of solution X plus ammonia, aqueous ammonia in drops, then in excess, Now that's the second analysis. Now what I will say now, the second portion here adds ammonium, aqueous ammonia. Where is aqueous ammonia? You can see there's aqueous ammonia. I'm done with this now for now. So now add this. What do we see here? Just in drops. You can still see white precipitate. You can see it's becoming light, almost getting like white precipitate in drops. So white precipitate in drops, white PPT as well in drops. Then you see suspect zinc 2 plus and aluminium plus present or suspected. Now when you add this in SS now, which is almost turning to colorless, when you add this in SS now, see it is even turned, it has turned to the white precipitate has completely dissolved. I have not even seen any white precipitate again. So meaning that white PPT dissolves in zinc ammonium in aqueous ammonia. So meaning that zinc 2 plus confirmed. It's only zinc 2 plus that can dissolve completely in in aqueous ammonia. Can you see the difference between this and this now? In both cases, aluminium and zinc will dissolve in sodium hydroxide, but only zinc dissolve in in ammonia, aqueous ammonia. So that's about the second portion of the solution. The second portion of solution. Then the third portion now, we have to add the last portion of this solution X now and dilute HCl. Now, let's write it out now. The third portion now. Third portion of solution X plus dilute HCl. Now, plus dilute HCl, what do we have here? So, HCl is HCl. HCl plus is very important to observe this. Plus HCl, you can see there's an effervescence occurring now. Effervescence, you can see effervescence occurring. So that shows an evolution of the gas. So effervescence of the gas, and that gas, if you test it with lime water, it will change lime water what? Milky. So now effervescence of gas occurring, effervescence of a gas, which turns lime water milky. Now, which turns lime water milky, and the only gas that has that characteristic is CO2 gas from CO3 minus confirmed. Now, from here now, we have discovered that we have confirmed zinc 2 plus, and we have confirmed what? CO32 minus, which give us what? Zinc carbonate. So, maybe that we are done with what? The first salt, which is zinc triacylcarbonate, what? 4. Now, the next thing is to deal with what? The second portion of what? Of the second salt, which is the second salt here is aluminium chloride, but they won't call it aluminium chloride for you in the exams. It will be labeled what? Y. That's why I labeled it what? Y. So take one spatula of this, and then let's use this set of test tubes so that we won't confuse ourselves. So now we have our aluminium chloride here. Also, to this also we are asked to what? Add 10 centimeter cube of what? Distilled water. So I'll add one about what? So once add about 10 centimeter cube of distilled water as well. So now you can see there's an oily something here. There's an oily, it's a gelatinous what? Precipitate. It's before it's dissolved completely. We have a gelatinous colorless what? We have what? Here we have know that this observation, and which is what? Which is Y plus distilled water. Y plus distilled water. And the observation is that you can see C dissolved completely. You see dissolved what? C dissolved or Y dissolved in distilled water. But first of all, we both of us experience a gelatinous what? A gelatinous liquid, an oily liquid that later dissolved in water. So why dissolved in distilled water, which is the major thing, but you can see an oily thing during the process. So now we have Y is a soluble what? Y is a soluble salt. Y is a soluble salt. Now, we are asked to divide this salt also into 3 portions as well. So let's try and divide to 3 portions. We have 1, 2. Now to the first portion now. So the first portion of solution Y plus what we have is sodium hydroxide in drops. Sodium hydroxide, aqueous sodium hydroxide in drops. In drops. So what do you have in drops? Sodium hydroxide in drops. Now look at this here. You can see white precipitate here. White precipitate. So white APT form, white precipitate formed in drops. So what are the elements that are present? What are the ions that are present? Aluminium 3 plus as well as zinc 2 plus present. Then in SS now, let's see. In SS, do we have them soluble in SS? Let's see. SS sodium hydroxide. Wow. It dissolved in SS what? White APT. White APT dissolved in excess sodium hydroxide, aqueous sodium hydroxide. So we have the two also dissolved, both of them dissolved in what? So aluminium 3 plus and zinc 2 plus might be what? Present. They are present, they are very present. So both of it also dissolved in sodium what? Hydroxide. Now to the second portion, now I'm done with this. The second portion, I don't want to mix it up. The second portion here. The second portion we have add ammonium chloride drop. You can see white precipitate. You can see the white precipitate here in drops. So second portion now of what? Second portion of solution Y plus ammonia, aqueous ammonia, you understand? Aqueous ammonia in drops. What do we have? White PET formed in drops. Now it means that also we still have aluminium 3 plus and zinc 2 what? Plus. Now in SS, then in SS, what do we have? Then in SS, what do we have? You can see now that does it dissolve? You can see this persists. This also, you can see the precipitate persists. The precipitate persists, it does not dissolve. So now we have what? We have white PPT is soluble in SS. White PPT is soluble in SS aqueous ammonia. So aluminium 3 plus confirmed. Aluminium 3 plus confirmed, unlike this one. So aluminium 3 plus confirmed. You can see that it's not soluble. It's not soluble. Unlike the one that we did the other time that is soluble. So that's that. Now you can see this one, they are both soluble. Now look at this, they are insoluble. So that's why this is not soluble. Aluminium is not soluble in excess ammonia. That's the confirmatory test for aluminium. Now to the last portion of what? Of this solution Y. The last portion of solution Y. The last portion of solution Y now. Last portion of solution Y. Of solution Y. Last portion of solution Y. Last portion of solution Y plus HNO3 plus HGNO3 What do we have? Plus HNO3 plus HGNO3. What do you have? HNO3. HNO3 we have the HNO3 here. The HNO3 here is we have HNO3 here. We have acidified it now, and then so the last one here with this one now. If you observe that very well, you can see a white gelatinous precipitate. You can read gelatinous here. You can read gelatinous because amino has the ability to form oily substance on the wall along the wall test tube. So you can call it white gelatinous. So add HNO3 to it. So HNO3, you can see a light white precipitate. You can see a white precipitate forming. So this light white precipitate is as a result of chlorine presence. So see, you can see. So this is white precipitate forming. So this is as a result of what? Chlorine. So white precipitates formed. White precipitate formed, which is insoluble in HNO3 now, in HNO3 or HNO3. So now we said chlorine ion on what? Confirmed. They might ask you to add what? Then add ammonia to see the observation. You can say you should add ammonia to this to see the observation. What of us? Ammonia can dissolve the precipitate. You can see the precipitate forming now. White precipitate dropping at this. So that is the presence of what? Chlorine confirmed. So last portion of solution plus HNO3 plus HNO3 confirm what? Chlorine as the form white precipitate which is insoluble. So that's that about today's class. So we have come to the end of today's class. If you haven't subscribed, please do press subscribe button and notification bell. And that's all our educative videos on this YouTube channel. Another ways of what? See this question is that they may ask you to what? After dissolving what? After dissolving these X in solution, they might say should what? After discovering X in this what? In this water, they might ask you to add HCl, which causes evaporation, and from that resulting solution, they might ask you to divide that resulting solution into several portions. What do I mean like this? This is what we use for what? For X, this is what we use for what? Y. Now, after we have dissolved this X in water, they might ask you to what? Add dilute acid to it. Dilute acid to it, and evaporations will take place immediately. After the evaporation taking place immediately, they might ask you to separate this what? This resulting solution into 4 portions and then carry out what? Analysis. So they might ask you to separate it into different portions. So I'll work on it as I've done here. So you might say, okay, first portion of solution will take from here, add what? Zinc, add what? Add ammonia, add sodium hydroxide as we have seen it here. So we are still going to have the same result. So that's that about that. So if you haven't subscribed, please do well to press subscribe button and the notification bell. Keep on sharing this video with your friends and what? Keep on watching videos about academic tutorial. See you next time. Thank you and God bless you.